have any questions, we can deal with them. So what sorts of questions do we have from the homework? We still have 15 minutes on it, which we need to go. Number 13, we certainly can. Is that the one you just asked about? What? Okay, just a minute. Let's take a look at 13. We all have something slightly different. For there's my 13 right there. But I want to know what Allie's 13 is. Just a minute. Trying to wait. Okay, so let me put this down here. And so tell me precisely what you have. That way we can just do yours. Although, I mean, mine will be the same idea. But go ahead, Allie.
Mine's x to the 8 and then 2 to the 6.5x.
6.5? Are you sure it's 6.5? Why? Mine isn't that bad. I mean, well, I don't know, maybe it is. Mine's x to the 6th and then 9 to the 6x. Does anyone else have a decimal? You?
I have 5.5.
Oh, lots of decimals. I wonder why. Mine isn't a decimal. Okay. All right, we can do it. It's fine. Okay, so I'm going to do it carefully. I know you did it carefully. I saw. But I'm just going to do it also super carefully. So I've got f of x is equal to x to the 8th. G of, this is product rule here, by the way, is 2 to the 6.5x. So this I'm going to just name product rule. Sometimes it's easy to get distracted or get confused about which rule you're using. And so you don't have to label these, but if you get something wrong on a test, for example, I will label what you did, and I'll also identify what you should have done. So sometimes you accidentally do the product rule instead of the chain rule. Here we have to use the chain rule and the product rule. But let's do the product rule first. So f prime, easy, right? X to the 7th, there it is. So g prime is a little bit more complicated, so I'm going to do the chain rule. So let's take this and do the chain rule for this. So in this case, my chain rule, f, would be 2 to the x, and g would be 6.5x. So this here is the chain rule. And I know some of you probably didn't even bother writing this down when you got your g prime. That's fine. But I need to just make sure I do it all correctly. So here, little f prime, or purple f prime, is natural log of 2 times 2 to the x. By the way, if that was 3 to the x, it would be natural log of 3 times 3 to the x. Or like mine over here, this would be natural log of 9 times 9 to the x. But here I've got natural log of 2 times 2 to the x. And then g prime is 6.5. Okay, so that's the purple stuff, and that was just to get me to do the correct thing up there. So the correct thing up here is, let's see, that's going to be natural log of 2 times 2 to the 6.5x. I didn't leave myself enough room. Just a minute. I'm just going to slide this over just a bit. There we go. Okay, so what I've written so far is f prime of g of x. I have to multiply by g prime of x. So multiply by 6.5. Ooh, it turned fuzzy. Let's see if I can fix that. 6.5. Good enough. Okay, now let's put it all together up here. Finally. So I'm doing the derivative of this stuff. And I'm using the product rule from the stuff in red. So first of all, x to the 8th times ln of 2, 2 to the 6.5x times 6.5 plus 2 to the 6.5x times 8x to the 7th. And I realize I might have done that in a different order than you. In fact, I know I did, because I just looked at your thing. So let's write this 8x to the 7th times 2 to the 6.5x plus, let me rearrange all this, 6.5 natural log of 2 x to the 8th times 2 to the 6.5 of x. There. Is that what you typed in?
No, I need to keep the 6.5 on the 2.
This?
No.
That?
Yeah.
Yeah, keep it up there. It disappeared, it should stay. Wow, so much work. Phew. Okay, it's gonna be all right. But that's at least number 13. And hopefully you can translate that into whatever your 13 looked like, and you can see where everything went and wherever it came from. All right, is there anything else that we need to deal with that caused grief and suffering from this assignment? Yeah, what do you say, Sienna?
Question, 8 and 10.
Both of them?
No,
Pick one. Which one do you like best? Or worst?
Probably question 10.
Okay, we'll do 10 first. I just want to make sure we have enough time to do your favorite. And then we can do the less favorite one. Okay, so this one. So Sienna, what would you suggest? Which rule do you think I'm going to use while I copy this down?
Yeah, particle?
Nope, not the particle. Cosine inverse.
Oh. Would it be just like the arc?
Oh, that is the arc cosine, yes. But there's a rule. I'll put it up here. So I'll write it as arc cosine because that's much cooler to do it that way. So there's a rule. It's either going to be the quotient rule, the product rule, or the chain rule. And yeah, it's not the product rule, so it is the chain rule. It's the chain rule because you have one function evaluated at another. Let me write this down. Arc cosine. And then g is 6t to the 7th. And then f prime is -1 over the square root of 1 minus t squared, I guess it is. And then g prime is going to be, oh no, how did that just switch on me? What happened? I mean, I didn't do anything. I just moved my, let's see, can I get that? It was weird. It just slid right across. Must have been some weird 5-finger. Oh yeah, look at that. If I move all 5 of my fingers across, can I go back? I can. It's like a miracle. Can I go over here? Okay, sorry. Okay. Anyway, G prime. What's this? 42? T to the 6th? Does that look good? Okay, and then the rest of this is straightforward because you're now going to take all of this and you're going to write down f prime of g of t times g prime of t. That's the chain rule. So in our case, it's -1 over the square root of 1 minus 6t to the 7th squared times 42t to the 6th. That's a mess. Hopefully it'll let you just type that into your answer. You could simplify, well, you could combine exponents, but I don't know, it's risky. Because I know that you guys don't do the best when you're dealing with algebra. So avoid algebra at all costs. I know that's what you do with your calculator.
We got algebra very well.
Yeah, you programmed it. So I guess you must know your algebra to be able to do that. All right, so that was number 10. Looks like we have a couple more minutes, so we can maybe get to 8. You said 8. Let's
I
take a
feel like
peek.
it's the exact same. I just completely blanked on how to do both of them.
8 is exactly the same. In fact, I can tell you the answer to mine. Oh, wait. What do you have? Read it off.
I have sine to the -1 correct.
Okay, so your answer is going to be 1. No. Your answer is going to be 2 over the square root of 1 minus 4x squared. Type it in, be happy. But yeah, it's basically using the chain rule and with a arc tangent, arc sine.
I was just trying to do it last night and I completely just blanked on how to do it.
Well, see, the problem is it was 2 a.m. That's last night. You should have done it at 9 p.m. or something. Or get up and come see me at 6 a.m. I actually had someone in my office at 7. It was wonderful. Kelsey, what's going on?
So for the derivative of x to the e, is that just e times x to the e minus 1?
That's exactly right, because e is a number.
I can't type that in and move them. It keeps like moving the minus sign outside of the X.
Ooh, fascinating.
Oh, I had that same
Put it in
thing.
parentheses.
I
You can also just literally put the exponent without sign, and then it'll just make them together.
Which one? Oh, that's this one. I thought that was cute. I guess it was too cute. 20, let me see. 20 times e to the x plus x to the e. Oh, I see. Yeah, parentheses. Okay. There we go. Let's see if it likes me. Yes, it likes me. Very good. Very good. Anything else? We're good? Yeah? Good. Yeah, so apparently the problems I have for you hopefully will be easier than that. Let's see how you do. I had warned you, this is a bunch of them, but you should be able, these should be in your head. You should be able to stick them on the paper quickly. So by the time I get back to Zach, Elena will be done.
Oh, yeah.
Maybe.
Sounds
Yeah.
like.
There we go. There's a couple. Is that two or one? Don't worry, Zach. I'm not going to neglect you. You're almost there. There. Enjoy. Are you okay? You're good? You're back in the system. good. All done? Check my work. Hopefully I did it right. Nice. Looks good. It looks great. Good job. Nice. All right, I think I got them all. Did I have them all? All right. A couple of years ago, I guess it was during the pandemic, a couple of engineers, three of the engineering students wouldn't have graduated because they needed differential equations. And so I said, okay, I'll do it remotely or whatever. So I helped them graduate, and they gave me this mug with my favorite integral. Actually, it's a derivative on here. So that was the answer to one of them, at least. I don't know if you can see. They had engraved the derivative of arctangent on there. But anyway, so there's that. That's the answer to one of them. Which one is it? It's letter B, 1 over 1 plus x squared. So let me just whip through these. Let's see how quickly I can do this. Derivative of 4x cubed, 12x squared, minus plus 6x to the negative 2. Look at that. 1 over the square root of 1 minus x squared. This is going to be 2e to the 2x. This will be negative 5 sine. So you should be able to, you should strive to be able to rattle these off really quickly like this. 1 over x for this. I think I missed one up here. Yes, tangent is secant squared. Like associate these things right with one another so that when you're doing whatever calculus problem you're doing, you don't have to look them up. You can just use them. So natural log of 2 times 2 to the x. This is going to be 1/3 x to the negative 2/3. I realize that some of these you might have to actually write out. You might not have them as quick as me. That's going to be a product rule, isn't it? So this is going to be x squared times 1 over x plus 2x ln of x. So I guess that'll end up being x plus 2x ln of x. Kind of nice, those things cancel. All right, I think I got them all. I got them all. Woo! All right, we're moving on. So today we're doing a technique called implicit, I can do the 5-finger move. Wow, that's exciting. Oh, this is life-changing. Well, I wouldn't call it life-changing, but, it's gone away. Which direction? This way. Well, it's just, because I always have to go, I don't know. Doesn't matter. Okay, so implicit differentiation. What in the world is implicit differentiation? Well, implicit differentiation allows us to deal with functions that are implicit, not explicit. So what is an implicit function? So here are some examples of explicit functions and then implicit functions. I wouldn't copy these down other than just to note the pattern here. Notice the pattern, the relationship that on the explicit functions you have either f of x equals something or y equals something. And that something is a function of x. So in both of those cases, you have a function. This is what you're used to dealing with up here, the explicit functions. The things down below are implicitly defined functions. In fact, they're not even functions at all. For example, this first one, this one, does anyone know what that makes if you graph that on an xy? Like, you know what sine of x looks like? It looks like this, whatever. But do you know what x squared plus y squared equals 4? You know what it is?
Does that just make a dot?
Nope, it's bigger than a dot, but you're on the right track. Yeah, we can.
Circle?
Yeah, it's a circle. So imagine a big dot. So it's a circle, and it's got a radius of 2. So that actually is this thing here. Not a function, right? Calculus, or not calculus, pre-calculus. Pre-calculus, you have this drilled into your heads that functions have to pass the vertical line test. This does not, because right about here, the vertical line crosses this curve in 2 places. But despite that, we could still think about slopes at various points on this curve, and it might be important to figure out the slope of, points on a curve like that. I almost digressed, but I'm going to stick with it. Just keep it here. Okay, so xy equals 1. That one is actually a function, but the way that it's written, it's implicitly defined. So implicit means that the x's and the y's are somehow, you don't have just y equals a function of x. You have other stuff going on. Xy equals 1. That one, by the way, is the function y equals 1 over x, this hyperbola. So you may be familiar with that function, but it's a function. But here, that function has been implicitly defined. And then this last one, I have no idea what kind of curve or graph that looks like. But we could think of that as having maybe a bunch of functions implicitly defined there. By the way, the circle actually has 2 functions embedded in it. I don't know if you've ever tried to graph a circle on your calculator, and some of you may know about polar coordinates, but if you don't use polar coordinates, the only way to graph this thing is to graph it in 2 pieces, and then you basically are dividing this into 2 functions. That's the top half of the circle, and the bottom half is the negative of this. I can remember back when I was literally in middle school, when I first got my hands on an Apple II computer. This is the thing that came before the Macintosh, which came before the MacBook, which came before the iPhone and all that. Anyway, Apple II, and I learned how to draw graphs. I was like, oh, I can draw a circle, and I realized the only way to do it, at least back then, was to divide it up into 2 pieces, because the coordinate system was all Cartesian. Anyway, getting back to this, this is actually 2 functions embedded in that one expression. And then this one, I don't even know. Like I said, I don't know what that looks like. I suspect that that's multiple functions. Like if you were to graph that, it's probably going to look like all kinds of weird stuff. But, because of that cosine mainly. But it's got some implicitly defined functions embedded in it. So how do we deal with slopes? This one is easy because we can just divide things out, but I want to deal with the slopes implicitly. So what we're going to do is, let's see, do I have something here? I don't like that. I'm going to, just a minute, let me go over here. Let me go over here just briefly, and we'll talk about this one. X squared plus y squared equals 1. Let's do this. We'll get the derivative of this. Derivative, remember, is slope. Derivative is slope. So I want to find the derivative of this thing, and then we'll talk about the rules, how to do this. It's not that complicated. So let me find some volunteers. Here we go. All right. I know you're scared. You don't want to. No, it'll be easy. Trust me. Trust me. Just use your intuition. It follows exactly what you would think. It goes the way that you would think it would go. Sienna, what is the derivative of x squared? 2x. Look, we all know that. 2x. So if I want to do the derivative of x squared, I get 2x. Okay, next one. Allie, what is the derivative of y squared? 2y. Makes sense, right? Plus 2y. I'm going to put a little bit of a little box here because there's something missing that I'll explain in a minute. Allie did a great job, though, by the way. Perfect. And then we'll do the last piece, and that's the derivative of 1. Kelsey, what's the derivative of 1? 0. It's a constant. 0. That's all you've got to do, by the way, for Monday. That's it, except for the box. Let me explain the box. So the box, what that represents is the fact that y is an implicitly defined function of x. And so this here, instead of writing it as y squared, think of it this way. Here, I'll do it this way. Y squared is equal to some function of x squared. So when we think of it this way, let me just go one more step and get rid of the y. There. You've got some function of x that's been squared. If this was what I gave you, you well, hopefully, maybe, I can always wishful thinking on my part maybe, but let's pretend. When you approach this, and if I asked you for the derivative of this, you would think of the chain rule, because you have something here that's been squared. Like it could be sine of x squared, or it could be tangent of x squared, or it could just be the square root of x squared. But whatever it is, it's something squared. So when you do the derivative of this thing, what you end up with is you end up with that 2 times that something squared. But the chain rule says I have to multiply by something else. Do you know what that something else is? No one knows? Come on. Not x. Okay, let's actually do it. Let's say we had the derivative of, we'll pick something easy, sine of x squared. Okay, so we're going to do 2 times, leave the sign alone. Chain rule, though, says, here I know that you know this, Thomas, what do I multiply that by? And what is derivative of sine? Cosine, yeah. There it is. So cosine. Okay, let's do one more just to have fun with this. Well, I know you're not having fun at all, but I am. Arctan. Okay. And this is going to be 2 times arctan. Oh, that's squared. Arctan times, all right, Ethan, what do I multiply that by?
That would be that on the back.
Yeah, I know. I was a little disappointed, to be honest. I wrote them a thank you note. But I was a little disappointed that it doesn't pop a little bit more. Like, it's hard to see from that.
Yeah.
That, yeah. There it is. Like, I don't know. I appreciated the thought, though. And it does say at the bottom, thank you, summer 20 differential equations. So, anyway, I'll do it. Yeah, it's the thing on the mug. So that's 1 over 1 plus x squared. It's the derivative of arctan. By the way, as you can see, it is one of my favorite functions. So definitely that will be on the next test. So just be forewarned for sure, arctan. Okay, so anyway, there's sort of the pattern. Notice the pattern is you take the derivative of something squared, it's going to be 2 times that something times the derivative of the something. So going back up here, the derivative of this something squared is going to be, oh, I blew it, didn't I? Maybe that was what was confusing. Sorry. Anyway, now that I got it straightened out in my head, hopefully it'll be straight in yours. It's the derivative of anything squared is going to be 2 times that something times the derivative of that something. That's the chain rule, at least the chain rule as it applies to this particular case. So up here, since y squared equals f of x squared, when I do the derivative, I get 2 times that something, so this is y squared becomes 2y, then multiply by the derivative. And I'm going to write the derivative like that, y prime, just to make it easy to see. Or I don't know if it's easy or not. I feel like in the past I've had students complain one way or the other. I forget which way they complained about. Well, we'll see. If that's a problem, we could always write it like this. I don't know if that's better. You choose for now. That's better, yeah? Because it doesn't get confused with y. Okay, we'll go with dy over dx. dy over dx is fine. Okay, now that I've got this, check it out. I can actually compute or solve for dy over dx using algebra. So dy over dx is going to be negative 2x over 2y. I realize I can cancel the 2's. I just wanted to have something to show you. That's implicit differentiation. I have the slope. The slope is in terms of both x and y. That's fine. But I have a slope. So if I know an x and a y coordinate, for example, the coordinate could be the radical 3 and 1. Radical 3, 1 is a point on this circle. So radical 3, 1, x equals radical 3, y equals 1 is right here. Radical 3, comma 1. You can actually see there the slope is going to be negative, isn't it? Well, let's see what it is. Put radical 3 in for x, 1 in for y. You get negative radical 3 over 1 after canceling things. And so negative 1.732 is the slope apparently at that point. All right, I know it's super uncomfortable, so let's see if we can make it less painful. Let's go back here and do some examples, because that's doing a few examples will help, hopefully. Take a look at this one, see if you can work this one out. Get dy over dx. So remember, just do the derivative completely naively, except for whenever you do a derivative that has a y in it, tack on a dy over dx. That's pretty much it. And we'll be done early. Well, no, we won't be done early, trust me. There's some more complications. But. All right, we're doing it one step at a time. We're going to take this slow, because this is hard. Well, actually, this one isn't all that hard. But Zach, what's the derivative of y squared?
2y.
2y. And since I just did the... Yeah, so this is only when you do a derivative of y. That's going to be important. Later, you'll see there's going to be some additional complications they're going to confuse a bunch of people. Elena, what about the derivative of 2x squared?
4x.
Excellent, good job. So I'm going to just put plus 4x. And then I got one more derivative. Oh, you're not here to do it. Zach, it looped back around. What's the derivative of 4? 0, very good. Now all we have to do is a little bit of algebra, and you should get dy over dx is equal to negative 2x over y. After canceling, it'll be 4x, negative 4x over 2y, and then cancel. Hopefully the algebra isn't going to be terribly challenging. But there it is. Does that look all right? So now, whatever curve this was, we can find the slope of this curve. By the way, there's reasons. I know I keep promising you that we'll get some applications. For now, just think of it as a puzzle or a game. But once we get to those applications, we're going to want to be able to do this sort of thing. Let's try another one. Let's see. This one looks super easy. Oh, no. Okay, so this one is the first one that is going to cause lots of confusion. So I just want to be forewarned. This one. I know it looks just as easy as this, but it's going to cause some suffering. So let's deal with these things one at a time. In fact, I'm going to save the best for last. We're going to save this one for last. Let's go from right to left instead of left to right. All right, because some of these are pretty easy. Ethan, what's the derivative of 3x? It's just 3. Very nice. Sienna, what's the derivative of negative 2y? Negative 2. And then since I just did the derivative of a y, I do dy over dx. Okay, xy. We're going to use one of the rules. So here are your choices. You can choose the product rule, the quotient rule, or the chain rule. Technically, anytime you have a y, you're going to use the chain rule, but that's not what I'm talking about here. I'm either going to use the product, quotient, or chain rule. So pick one of those, and we'll see if you've got the right one in your mind. So Kelsey, what one do you have in your mind? Product rule. You have a product, don't you? That's the one, by the way. X times y. So I'm so tempted not to do this, but I'm going to. F is equal to x, G is equal to y. Product rule. So this stuff right here is going to be over here. So I'm going to do my work over there, and then I'll put the answer down there where it belongs. Okay, so f is x. I know it's kind of hard to see, bright green. Okay, that's all right. All right, Elena, what's the derivative of x?
1.
Okay, that was easy enough. Very nice. Allie, what's the derivative of y?
1.
And since I just did the derivative of y, what do I have to add to that? That's right. Okay, so here's where this is the part that is going to be confusing. And that is that when you do something with the product rule or the chain rule or the quotient rule, whenever it involves y, you only put the dy over dx on the portion of this rule that involves the derivative of y. So it's only when I do the derivative of y, which Allie did perfectly here, derivative of y is 1, that's when I tack on a dy over dx. I don't put a dy over dx over here. Okay, so let's put this all together. F times g prime plus g times f prime, or whatever arrangement you want for this product rule. I'm going to write it over here, and then I'll copy it in red, so it'll be easier to see. So we've got f times g prime. That's x times, I'm going to leave out the 1 if that's okay, dy over dx, and then g y times f prime. I'll put the 1 there just to emphasize, but this is just dy over dx. All right, let me put it over here, and then we'll see what sort of complaints you have. So I've got x dy over dx plus y. I think this, so implicit differentiation is not hard. It's not at all. I mean, what I mean by that is this form of it, where you have the x's and the y's, they're all separate, we're all happy. That's not bad. You just have to remember to throw a dy over dx in everywhere you do a derivative of y. What makes it hard is whenever you throw in a product or a quotient or a chain rule, on top of the implicit differentiation, it's almost insurmountable. This is hard. So cut yourself some slack, and cut me some slack too. But have patience as we try to work through this. So what sorts of issues, questions, concerns? Maybe you see it, like it's easy when you see it. That's another thing I've heard. It's like, yeah, when we do it in class, I understand. And then I go home, I don't get it. It's fine if you're like that. Everyone's like that. So don't fret. Oh, whoops. Okay, so this looks okay. So now we just solve for dy over dx. That's not bad. So I've got x minus 2 times dy over dx is equal to 3 minus y. Check that I did my algebra correctly. I mean, because this is just algebra, but algebra can oftentimes trip us up. dy over dx is 3 minus y over x minus 2. There it is. There's my slope. So that would be the slope if I needed a slope. Right, what's coming up? I want to get something that's not terrible. That's not bad. All right, let's give this a try. Yeah, I mean, I know what's coming. And I need to have patience as well, so we'll all work together on this. Now, I don't know about you, but when I see this, oh, wait a minute. I don't like this one at all. Because there's a temptation to divide both sides by x. Does anyone see that? Don't do it. Because we need the implicit derivative. And if we get rid of the x, then, yeah. If the x goes away eventually, that's fine, but let's not get rid of it yet. Okay, so you have two products. Yeah, maybe I should just put a plus 1 over here. Yeah, let's do that just a minute. Yeah, change this. Yeah. Now you can't just divide by x. Well, you could, but you still have problems. but I've got two product rules I have to do. See if you can set up your product rule correctly. Let's just do this one right here. See if you can set it up and execute it. And if you can, then the second one shouldn't be too bad. But let's do the first one first. See if you can do it. All right, let's see how we're doing. Where am I on the list here? I think I'm down to Allison. Allison, how did you break this up in terms of F and G? Cosine of y, very nice. So yeah, it's a product, separated out into x and cosine of y. All right, Thomas, what are the derivatives? What's the derivative of x? That's 1. And what's the derivative of cosine y? Just that? Yeah, that's right, with that thing. Don't forget that thing. Every time you do a derivative, it's only when you do a derivative of y, which I just did. Throw that on there. Okay, so let's see if we can put this all together. I've got f times g prime, negative sine of y dy over dx, plus cosine of y times 1. Excuse me. There it is. So that's that left-hand side. I know it looks like a mess, but it's correct. We're doing okay. Okay, so next we're going to want to deal with this 3xy. It's a product rule as well, but we kind of did that product rule just a minute ago, didn't we? We did it right here. It's in green on the right. The only difference between this one and this one is that this one is just xy. This one is 3xy. But it'll work out the same. I mean, I could put it in here. Here's with the, that'll be 3. This will be 3. This will be 3. So the only difference is down there. But we did it once, so I don't know that we need to write it all out again. But if you do need to write it again, there. And I guess I just wrote it sort of in the green there. You can also check out the video. Fast forward to, I don't know, tell me how far we are. I don't see a time thing. I'm sure that if I could click something, but I don't find it on there. But anyway, you fast forward to about 40 minutes in, and you'll find this. But anyway, getting back to this, there we go. So now we've got the other side. What was it? 3x dy over dx plus 3y. Don't forget this 1. Well, if you do, it's not going to be a big deal because the derivative of 1 is 0. All right, how's that look? I know this is uncomfortable, and it's going to cause a lot of grief over the weekend. But take it in little bits. Don't like do a little bit today maybe, and then a little bit tomorrow. That way you get it done early. Okay, let's solve for dy over dx. First thing that I'm going to do is I'm going to move all the dy over dx's. I'm going to move them to the right side. And the main reason is because I noticed that this is negative. You could do the other way, it's fine. But so I'm going to put the cosine of y minus 3y on this side. On this side, I'll do this. How's that look? So basically, I just took the 3y over here and moved it over. It became negative. All of this mess over here became positive because it was negative. You know that, change the side, you change the sign. Whatever trick you remember from your algebra class is fine. Let's factor dy over dx. Oh no, it went away. Here we go, let's do this. Sorry, I have to watch what I touch. Okay, dy over dx, 3x plus x sine of y equals cosine of y minus 3y. And then I've kind of left myself some room. I really didn't, did I? So I'll do it up here. And I'll do it in black. In a box. dy over dx is going to be this fraction cosine of y minus 3y divided by 3x plus x sine of y. Beautiful. This is hard. I'm just being honest with you. It's difficult. So don't feel like it's going to be super easy. So, for example, let's say that you want to find the. Let's see, what could I do here to make this easy on myself? There's nothing I can do to make it easy on myself. Yeah, this one's hard. Yeah, I don't want to. I was going to pick a point on that curve, and I just realized whatever I pick, let's say I pick y equals pi over 2, which would make this 0, but then this won't be 0, and then I'd have to have 3x times pi over 2 plus 1 equals 0. So, anyway, to find a point that's on the curve is what I'm saying. It's going to be a bit of a pain. Well, I guess if x is 2 over 3 pi, negative 2 over 3 pi, and y is pi over 2, then that would work. Well, anyway, if you wanted to find the slope at that point, you would plug pi over 2 and negative 2 over 3 pi into this for x and y, respectively, and compute your slope. I don't want to do it. Okay, so what do we have here? There's got to be a couple of these that we definitely want to do. Yeah, let's do one more. That's not hard enough. Okay, yeah, it's okay. I guess it's okay. No, actually, that's annoying. That one's annoying as well. We'll do this one. This one's easy, but it's not annoying, at least. So give this one a go. No product rules here, no chain rules, no quotient rules. So this one should be easy. And while you're doing that, I'm going to take a peek at the homework. So I want to make sure that nothing too egregious is on the homework. Okay. There's one that I think maybe I'll mention once we get done with this one. Yeah, I guess I must have filtered out all the hard ones from the homework because the homework doesn't look terrible. Could be worse. So when you do your homework, just remember, could be worse. All right, let's do this. Because, yeah, once you get started, it's really not all that tough. So where am I on my list here? Allison, what's the derivative of y cubed?
3y squared
Beautiful, very nice. Kelsey, what about the derivative of negative 3y squared?
negative 6y.
Pretty close, by the way.
Why is it frozen? Yeah, I guess so. Oh, yeah, it's right there. Okay. Yeah, you did a great job, Allison, as you can see. Copied it down perfectly. Kelsey, finish it up for me. 6y times what?
Times dy over dx.
Very nice, good job. Dy over dx. Sorry, I messed up there. All right, who's next? You're not here. Sienna, though, you are here. What's the derivative of 4x?
4.
Beautiful. And then we have Thomas, derivative of 2x squared. All right, almost done. Last thing, Ethan, bring us home. What's the derivative of 10?
0.
Beautiful. So now we just have to solve this for dy over dx. Look at this. I can skip lots of steps, can't I? This is going to be 4x minus 4 all over 3y squared minus 6y. Impressive, right? But there it is. You probably could factor some stuff out. Okay, so let me show you the homework, just a couple of tips and tricks so that you don't go nuts. This is the last problem on the homework, and at least the way that this looks, so here, the way that it's written, if I was doing the derivatives, on the right, there's no problem. 25x squared, 25y squared. Do the derivatives, you get 50x and then 50y times dy over dx. That's easy. It's the left here that's a little bit of a problem, and you have two choices. Either you can apply the chain rule carefully, so multiply by 2 and then do the derivative of what's inside here, or you can square that binomial and you get x to the 4th plus 2x squared y squared plus y to the 4th. Don't forget the 2 out front. You might have different numbers than me. Oh, can I get another version? Oh, I have to put something here. Yeah, and then they want the slope, the tangent line. Yeah, I didn't get it right. Get a similar question. I was just curious to see how different. It looks the same. Just a minute. Let me try one more time. Get a similar question. It's the same. This point is changing?
Yeah.
Oh.
I think it was 3 and negative 1.
Well, whatever. But anyway, so apparently they're going to be very similar to this. So that one gave me a little bit of pause as I looked through, but either square this or do the chain rule a couple of times. The rest of this stuff is pretty straightforward. Notice that it's all polynomials. That one's going to be easy. This one, the only thing that's weird is this x times y. That's easy. There's an x times y here. Good thing we did a bunch of them. And then the rest of this is just a multiple guess, which I guess you can try a couple times before you get it right. So, all right, look at this. We're done a couple minutes early if you wanted to stick around and chat. Otherwise, I hope you have a great weekend. Get some rest.